Yes,
talked about. These are the major things we talked about. Am I correct?
Yes, yes, sir.
So it was respect to gold. But today we are going to be dealing with rare elements. We're going to be quickly looking at the rare elements, why we actually pick some of these minerals. We're looking at some of the critical metals that are very, very important and of high economic value as it stands to the modern technology, modern technological advancements, or in terms of what is actually in demand. You know, for me, I've read geology. I've moved from geology, reading geology, to economic geology, to making an impact to society. The essence of being a geologist is actually to find some of these deposits, find minerals that the world will use to advance technology. That is the essence. If you're a geologist and you can't find a mineral, definitely you should find your way in some other things to do. So, and again, there are two things you should understand: finding minerals for academic purposes and finding minerals for economic purposes. They are two different things. For literature review and literature research and other genetic source understanding is different from finding an ore deposits. The ore deposit is actually a commercial mineral. So that is actually what is, that's actually what everybody wants to find. So you should understand that your essence of being a geologist is to find economic deposit of minerals so that you can contribute to the advancement of technology. So the rare element, which is some of the minerals that actually they occur together. There are about 17 of them. Why do we call them rare? From the English word, you understand that they are rare because they are not common. And minerals or metals are costly based on the rarity of that particular mineral. The rarer the mineral becomes, the costlier it becomes. The gold is costly because you don't see gold everywhere. You understand? The rare elements, the cesium, the praseodymium, all of them, cerium, all of them are very rare. They are costly because they are not common. And when you talk about the modern technologies in terms of aviation, please, can you put down your, in terms of aviation and everything, you find out that those elements are the things that are not common and are that actually what is required. So today we're looking at the rare elements. Some of them we have about 1 hour for this training, and I will show you some live. I think we started last time. I showed you some database from what we did last time. The same database, we are getting a lot of other anomalies from there. So we keep on trying to interpret them to make sense, and for us to be able to further our what do you call it, our discussions on this. So when you are talking about the rare elements, as it is, we want to apply soil geochemistry to actually understanding these minerals, right? So can you see my screen right now?
Yes.
Yes, sir, we can see it.
Okay. Right now, I'm going to mute everyone. So that it does it. Now, okay. Hide. Okay. So that it does it. Then we're going to be looking at applied soil geochemistry as it is related to rare elements and critical metals. We're going to look at some of the anomalies we've got from a particular location and see how this has actually, how we can further such exploration. So I'm going to be showing you some live data anomalies we've got. Then, but I also want to tell you how this is, actually how it's faring when it comes to the markets itself, because it's very important that you understand, what you are doing when it comes to looking for a particular kind of mineral. Okay. So, as a matter of introduction, as we said, this actually is going to focus on the using of the soil geochemistry that we've actually done. We've actually done based on XRF data that was actually analyzed. And this, at the end of the day, we are able to find out some interesting anomalies that are actually associated with different elements. So, if you look at this now, we've identified which is the lanthanum, the praseodymium, and the cesium, the cerium, the phosphorus, the potassium, the aluminium, the neodymium, which is the ND. Now, what we've tried to look at this place is, after seeing these anomalies, we understand that these elements, the La, the Pr, the Cs, are very important in terms of rare elements. So having them popping up and all that, we're looking at their concentration, especially when they are above 1,000 ppm. We'll start looking at how they are, some are 2,000 and some are 3,000 and all that. Already you know that aluminum is more in abundance, but why we look at aluminum is also we look at aluminum in line with other mineral like the lithium. The lithium is aluminosilicate mineral. Because it's aluminosilicate mineral, it is expected, and in all the feldspar, the pegmatite is aluminum. All of them are, you see, they have a high content of aluminum. So definitely aluminum is something that we can look at in any particular environment that has pegmatite to be very, very high. You understand, at least. But if we see anything that is in the neighborhood of 20%, 25%, 18%, it tells us an interesting potentials of that location in order to look at if that location is actually geologically fractionated environment or evolving environment or environment that has been enriched with a kind of a particular kind of mineral. So that is the essence of looking at it. So in any soil geochemistry that you've identified any particular metals, any particular elements, and the concentration of that element is actually an outlier, or you see that it is above normal, you start following up on that particular element. So what you need to do is to start identifying other pathfinders that actually hover around that particular kind of minerals. You understand? So now, where we've done some work here is in Nasarawa. Actually, the Benue-Nasarawa metallurgic belt, it has been an interesting belt that is actually composed of mainly most of the granite, pegmatite intrusions in various locations, and also linked towards the alkaline complexes of Jos Plateau, all of you understand the geology of Jos Plateau, the younger granite, what it yields in terms of the tantalum, the tin, and even some accessories of gold as part of its elements. Now, also, we all know that in that location, Nasarawa has been a very a home for pegmatites, which some are fractionated, some are not. And this, we're actually looking at pegmatites that are actually fractionated that are highly favorable for REEs and other critical metals. So that's why we've looked at this geology and looked at a particular location to be favorable and have high potentials for this. You understand? So looking at it, the tectonic setting of this location actually supports that there should be some presence of REEs. So we said the REEs, what are they actually? When you talk about REEs, what are they? These are some of, like the name implies, I say that they are rare. They are not common elements, but they are in group of 17 of them that are, they have some chemical. Before you group anything, there should be some chemical similarities or properties or characteristics that actually bind them together. So despite their names, we also know that some of them are relatively abundant on earth crust, but they are even rarely found in such a manner or concentration that they can be economically mineable. So we look at these REEs and they are grouped into the light REEs and also the heavy REEs. When you look at the light REEs, the light REEs are this one that we've actually said here, the lanthanum, the cerium, praseodymium, neodymium, the promethium, and also you can see the PM there is also a radioactive element. And samarium, these ones are not all those that common. But I know that the LA, the CE, the PR, and the ND actually mostly are very common. But the PM and SM are not something that I will tell you that I'm used to. So if you look at the heavy ones are, you can look at them, the gadolinium. These heavy ones, you look at these heavy ones, I think the only one that is too common we see is the yttrium here. Other ones are not even yes. Which other one? The terbium also a bit, gadolinium also a bit showed up, but other ones are not something you see easily. The yttrium behaves like REEs, heavy REEs. I've seen this in some of my exploration. They've actually shown up, but I'm not sure I've seen any of these other ones in most of the work I've done. So that will tell you how rare they are. And we understand that because of this usage of these REEs, they're actually used in some of the modern technology that we cannot do without. In terms of the magnets, that's why the neodymium are very, very important when it comes to making of all these strong permanent magnets in EV motors and all that. The lanthanum and the cerium nickel metal hybrid batteries actually used also. And in terms of catalysts, petroleum and all that, you can use the cerium. And the yttrium is actually also used. Then if you look at the military and aerospace, they are also used, So this is, you can find out that the key uses of rare element is not something we can do without. You understand, comparing, looking at the way technology actually advances now. And if you look at this, the major producers and even processors of this mineral is China. When it comes to producers and processors go to China, they have what it takes to process. That's why all the lithium of the world almost find their way to China, because that is the processing hub. So they control the world market when it comes to do. But in terms of production, I know in terms of production, Australia is one of the best in terms of rock lithium production, and US also. Russia also do. So these 4 countries are well-known countries when it comes to rare element production and even the lithium production. But look at this, the common REEs, the monazite, which is in Nigeria. And that's why when we're talking about monazite, we'll see is mainly deposits that are actually found in placer forms. And they can also be found in granite and carbonatites. That's why when you are exploring a new location and you find anything that has to do with gold, and you find iron, and you find limestone, or definitely dolomites, that environment is an interesting environment. Do you understand? An interesting environment, especially when you find out that as later on we're going to discuss the essence of Ca, calcium, when it's elevated in any of your exploration work. It's actually very important to understand how those things influence, or how you can actually interpret the abundance or enrichment of some of these elements in order to link to some other minerals you are actually looking for. So if you look at this REEs, I would say that all of us will be mainly conversant with the monazites. So that it does it. Actually, why we started looking for this. Then looking at this element and other, why do they actually matter in exploration? It's because you need to understand their, first of all, the economic importance. If you don't understand they are very important economically and the value is very, very high, there won't be any need for exploring them, So because of the green technology crusade right now, everybody wants to go green technology, transition from the fossil fuel to all that. If you get into China, that's why if you get to China now, I think that is almost the major cities are all using EV vehicles because of the green technology crusade that is actually going on. The fossil fuel actually will stay continue for a very long time in the African continent. But I think we are the younger ones should be able to understand that there is high possibility of us making certain things actually known, discovering it. We have it here, but at the end of the day, do we process it here? No, we don't process it here. So we still sell it out, So also, if you look at the essence of exploration, is that because of the limitation of finding this, also the technology of finding it, and it's not like any other bulky mineral you can easily see, you identify because you've seen an outcrop and all that, So we should understand that this is why it is very, very important we understand how these things actually work out. High value exploration targets, especially in terms of laterites. The laterites can tell you a lot of things about this. Some of the laterites are actually capping some particular formations. The carbonatite, the pegmatite, and alkaline complexes are locations that are of very, very much of interest. Now, I've said it. If you looking at this as a group, definitely we've grouped them or categorized them into the light and the heavy. Now, if you look at this, I try to understand, make it clearer a bit why they are the other ones are actually called light and the other ones are actually called heavy. Now, if in terms of light, the light rare elements are actually, in terms of abundance, they're actually higher in abundance. If you go back, like what we said before, the heavy rare elements are not common. They're not common, And also when you talk about the deposit types, definitely the lighter rare elements are actually found in monazite sands and the carbonatites. Like if you go to the Just Plateau, you see more of it in the plexar forms and all that. And in terms of why everybody wants to go for plexar of it is because ease of extraction. It is easier to extract when it comes to the the plexar deposit type of it. And it's very more difficult when you talk about the REEs are very much difficult to actually extract. And the economic value also is moderate in terms of supply and in terms of price, but the heavy ones are very, very costly and they are critical, very critical for technology and military. So the uses, you will see that it is because of the rarity of the heavy ones. That's why they are costlier than other ones. And if you look at other geochemical reasons, why they actually categorized differently is also the heavy ones are strongly bound with together with oxygen, and they tend to stay mostly in a solid phase during geological processes. But the light ones can easily move; they are mobile. When minerals are easily migrating from one location to the other, you can easily track them actually. And because of that, they are, the exploration are easier, so they are mobile and easier to actually concentrate in a magmatic process, So this is another reason why they are actually not of the same category. So because of the effects, these actually affect how they are transported and they move, how they are concentrated in different types of rock and also deposits. Also, you need to understand the prices, what it looks like. if you look at the price, try to look at some of the recent pricing, mid-2025, you can see that ND price, you can see 68 to 69 dollar per kg. You see, then if you look at the BR is about 72 per kg. You understand? But look at the TB. Have you seen the cost? They are not the same thing. Are you seeing how high it is? Even look at the SC, $3,787 per kg. So the TB is 1,000. It's about roughly $1,000 per kg. You know, this is they are heavy REEs. You understand? So that's why they are very costly compared to the other one. You can see how many times they are. You can see that even Neodymium is just about roughly not more than $70 per kg compared to this one that is about 3,000. Imagine a mineral about 3,787 per kg. So that will tell you 5N purity and all that. So the prices are not actually the same thing. So this is why we should focus much effort in trying to understand how this could be found. At least applying any geochemistry. Sure, let me tell you, the most important thing in finding this mineral is we'll go down to also see some of the methods, how some of them are actually efficient and some that are actually not efficient. The only method you can use to pinpoint, actually find the mineral is actually geochemistry. Geochemistry. After you've used your geophysics and everything and all that, you said all this sort of things you want to say, use all method of geology, mapping and all that. At the end of the day, to confirm that a mineral is there, is just to understand the geochemical concentration of that particular mineral. So if you look at these market trends, Chinese actually control most of the things here. The most REEs oxides are holding steady, but those medium heavy REEs remain highly valuable due to they're actually limited in terms of supply. And also since April, export limitations on some REEs like NDs have actually made some of these things to actually move up, you know. And also there is this steady demand growth also that have made ND, because of the magnet demands, have actually made some of these things to actually go up. So there is drivers in terms of the value and market. So now what does that mean? That means that definitely once, because there is value, because there is demand in growth and everything, now it means that definitely there will be a high value focus, you know, for some of these stronger minerals, for some of these heavy ones, you know. So exploration need to be intensified. No matter how it is, we need to intensify exploration. We need to understand the best method of actually tracking them, because the REEs might be there, but definitely they are not found. Nobody knows they are there, you know. Imagine you finding scandium now, you know, look at the prices, it's very steep, valuable, and, you know, it's a target now everywhere. So what it means that we need to intensify every effort in terms of even knowledge, in terms of technical know-how, to understand how we can actually find these minerals. So the major takeaways from the market trend is that both, you know, DY and TB they are scarce and they are very valuable. You know, ND is very, very important now. ND and PR oxides are they are good for magnet production. So they're actually required. So you can look at the RE that are actually the real thing now. The scandium is also very rare and very lucrative. But I think the ND and PR is something we can actually focus our strength on, because I know I've seen it. I've seen most of our results and all that coming up. But some of other ones, the heavy ones, are not easily found at all, you know. But you need to understand how this works before you to be able to even have an idea of detecting them in your exploration. So now, why did we focus on this? In our exploration, we've been able to see an anomaly of the La, the Pr, Ce, Nd, phosphorus, and aluminum. These are very, very important because RE enrichment is typical in one, carbonatites, the alkaline rocks and granite pegmatite, laterite overlying some of the RE-bearing bedrocks. Now, where we are working, we've seen an interesting carbonate rocks. You understand? That is one. We'll be able to see some alkaline rocks. We've seen some granitic pegmatites. There is an interesting laterites in that location. So in terms of rocks, geology actually are there. So these are the first thing you need to understand and need to actually start looking out for. In terms of this, I think we might have a very opportunity to explore rare elements, the lithium, rock lithium. I don't talk about the salt ones or the salar or the clay ones, but for now, I know we'll have some strengths in terms of pegmatite lithium. So that's why when you are analyzing your elements, you have to look out for some of these ones. So in our exploration, this one showed up. So we have to pick it up and start deepening, start analyzing them in terms of what are they. You understand? Now, you remember that the monazite is just the Ce, the Le, the Nd, the thorium, and phosphorus. If you go back there, you see what we've detected. We have the La, we have the Ce, we have Nd, we have the phosphorus. You understand? Now, this one, the basanasite and the xenotime are not something we are actually say that it's actually common. We've actually seen, but the essence of picking out those major ones are because we've seen that there is a possibility of the Nd being high, the thorium being high. You understand? So we have to look at this enrichment of La, Pr, the C, the Nd, phosphorus, and ammonium. They might suggest some Re-bearing carbonatites or some alkaline intrusions. You understand? And also, when they are actually related to some laterites, there are some laterites definitely that are related to some of these REEs. So you need to dig in further to understand the potentials of monazite possibility in such locations, especially if they actually rich in monazite sands or some other kind of REEs. So that's why we are looking at that. Then you can look at the CSDP, the Cls normally there, the phosphorus, the potassium, and the aluminum as part of possible lithium, cesium, tantalite, pegmatite indicators. When we dealt with lithium exploration, we've been able to understand that LCT pegmatites actually are the ones that are actually associated with the lepidolite, the polysite, and other kind of lithium minerals. So once we are in any exploration and you'll be able to see that the CS, the TA is actually elevated. Tantalite columbites are actually elevated. Any element of this is an indication to be able to say, okay, let me narrow down and understand this, because most of the time you might not actually see them, definitely see an outcrop of them. Most people think that you are looking for lithium, you just come in and you see the outcrop and definitely you start mining lithium. No, some are actually subsurface, 20 meters beneath, 30 meters beneath the surface. So the exploration insight is that some of the hidden LCTs can actually be shown on the surface from just understanding enrichment of some elements like the CS, like the Ta, like the phosphorus, like the potassium, and high alumina. Yet, understanding that the first part is that also has some alumina. But when it comes to lithium, the aluminas are they are higher, usually about 20-25%. Most of the time, they are above 20%. So you actually need to understand that this is actually calling potential for your lithium, for tantalite or cesium kind of deposit. So also looking at some typical of REEs, like what is actually found in other places. There are strong geochemical signatures that actually links this thing, CS and potassium together. You understand? So that's why I say that at the end of the day, you also need to understand how you can look at some ratios. Some ratios of elements will actually give you an interesting understanding about the particular targets. You understand? So if in terms of lateritic enrichment of this, which was actually saying, this is also known globally in some other locations. We'll try to look at some other locations where this has actually played a major role. Like in Brazil, you understand that we have a very close geology with Brazil. Brazil, South China, at least Asia, they are different. But because of, we believe that Brazil and Nigeria, West Africa have a very close geology. So most of the things that I've seen in the Brazil, especially in the Eastern Brazil, are actually associated with the Western African countries. So the exploration insight on this cannot be overemphasized too. So you need to understand the lateritic enrichment of REEs. These ones are definitely, because if you are dealing with the soil sampling, definitely you are dealing with lateritic zones. So lateritic zones have a lot of things to say and a lot of signatures to portray from the soil. It is this soil that will give us an insight that definitely there is a very bigger potentials when it comes to this. Now, if you look at some of the exploration clues for this, the soil geochemical survey actually should be done in such a way that you do it from level of confidence and order. You can start with your 100 meters, you can go down to 50 meters, you can go down to 55 meters. You understand? So high resolution soil geochemical survey is very, very important. I think it's one of the most important when you're talking about REEs. You can now go down to start looking at some petrographic analysis in order to start looking at, you want to now identify which mineral is which, from your microscope and all that. Now, the easiest way to analyze is your XRF on ICP-MS analysis. But at least you can start with your XRF and before you go to ICPC analysis, because when your XRF has shown some indication of certain element, that is the essence. You can actually pick this thing in situ, and within a twinkling of an eye, you'll be able to understand that some element of what looking for is actually there. Then ground geophysics, which is radiometrics. Radiometrics is very interesting also because of the combination of thorium, uranium, and potassium ratios. When you combine these three radioactive elements, actually, they are actually associated with some structures that are altered. So when structures that are altered are fractionated, it tells you about the enrichment of certain minerals within such structures. So if you don't understand that a particular structure is altered, how do you understand whether this structure will contain? You might have about 10 structures, but all of them might not be mineralized. And even maybe one is mineralized and all that, because the fluid does not actually flow into all. So what you need to do is to understand. That's why some of these initial surveys, like magnetic and radiometrics and ground geophysics, be able to pinpoint some structural, some structures within a location of interest. You understand? So these are some of the techniques. Then before you now talk about, you've done that, you can now go down to do your trenching on your pitting to understand how variations goes with respect to depths. You understand? If you've done your soil sampling to the depth of 0.5, now you've done your pitting to about 3 meters or 4 or 5 meters, definitely you might need to see if the concentration are actually increasing in that particular location. If the concentration are increasing from what you saw from the top, definitely it is telling you something. But if it's not increasing, it it might tell you that just maybe a kind of a stratigraphic anomaly or lithological anomaly, or as the case may be, you might not be able to tell about the increase in concentrations. Because if at 0.5, I am having something of 1,000 ppm or 500 ppm, as the case may be, and I've gone down to about 3 meters, and I'm seeing 3,000 ppm and all that, that will tell me that definitely there is linking me to a particular pristine vein or the source of such an anomaly. So that's why at the end of the day, you are convinced within such locations and you've been able to identify the structure or the target areas. You now talk about going very deep using a core drilling rigs and that kind of methods. At least you can now say you want to drill down to 40, 50 meters. You cannot pit up to that. Then at that particular point, you've gone beyond the stage of understanding that the mineral is, at least you should be able to know that there's mineralization now. But what you'll be looking at for now is the economic ore in that location. That is actually how you have to define the depth and the continuity of those minerals using your core drilling. Then another interesting thing here is the high value geochemical indicators. When you have a high LA/CE NdPr, it tells you it's an exploration crew, that will tell you the degree of fractionation or degree of mineralization, or that this concentration is actually there. You understand? So not just seeing it at the surface, you need to plot out some of these ratios and see whether they are really high or not. It's just like combining the CS and RB to talk about the degree of pegmatite fractionation in LCT potential pegmatites. So these are the kind of things you use. Then you have to plot your potassium in terms of, if you're looking for, in terms of abundance of mica or feldspar and all that. So if you look at these ratios, they are very, very important plots when it comes to indicating or looking for high values of these minerals. Then also some other advanced exploration you can go on to start looking at. Like I just said, the ratios are very important. I use ratios a lot, and they are very important. Sometimes you might not really know if it is abundant in that particular location or not. The anomalies might just spread in a larger locations. But once you use ratio will bring it directly on top of where the particular source is actually coming out from. So these are some other kind of things you need to look at. Then the pathfinder elements are also very, very important. There are some element that is like a must. Like the last time we discussed about gold. You can't be talking about gold without talking about arsenic. You can't say the arsenic is low. That is where you have to start from the arsenopyrites in the quartz and all that. Then you now start bringing in some other things. So you might not actually see gold as an element in any of your soil geochemical survey, but some arsenic will actually show up. And if the arsenic shows up in such a way that is very high, you start thinking about other elements. You look at your copper coming up high, you look at some other ones. So that is why you need to put in some advanced exploration tips to some of these. Then other one is looking at, like I said, apart from the hydrothermal alteration, you also look at where there is fractionated. Definitely, you cannot identify where you have something that is highly economic, because where you do not see some of these pathfinder elements in that location, when your ratio plots are not actually giving you high readings, when the alterations are not identified, it becomes difficult to say, yes, that this REE, that will have to pursue it further. So if you look at some of these methods now, if you look at these approaches, you find out that in terms of these approaches, definitely you cannot take away that the soil geochem is like the ultimate. Now, why drilling becomes the final is that the drilling will bring it to life. Drilling will confirm everything. You understand? So at the end of the day, you need to start with your soil geochem. You understand? You need to combine your soil geochem, your geophysics petrography, and your drilling. These are the most effective exploration approach when it comes to rare element discovery. You understand? Understanding how to apply your geochem, understanding your geophysics, how to apply them and what actually to use, definitely you won't be able to, if you don't understand these four approaches, you won't be able to detect or discover the rare elements. Then what we've actually tried to do, like we've just said, in this, because this is a project, it's a live project we are doing right now, we're extending the soil sampling in a very tighter grid around that particular location. And we're going to also target some other geophysics around the location. I'll bring in petrography, and after that, we're going to be doing a deep pits and trenches. You know, when we do a deep pit and trenches and the concentration continues and all that, then we can bring in drilling. You see, so that is just it. Then some of these notables locations, like we just said, China is #1. Talk about Australia. I think we mentioned this before, and all that. Then we will need to, okay, the takeaway here, like I've said, you know, when it comes to soil geochemistry, it's not just about detecting your metals, it's about reading the geological story beneath your feet, just what you can actually see beneath your feet. You can use the soil geochemistry to actually do that. So what we want to do now is to actually follow up the REEs potential locations, having seen that the geology is good there, having seen that the structures actually been identified. Now, the next thing is to go on with some tighter soil geochem. You know, we have to follow it systematically, fixed exploration program. At the end of the day, we are integrating the geochemistry, geophysics, and the drilling will come in to actually see the entire thing actually the way they are. So you can also look at some of these materials, USGS Rare Earth Element Resource Reports. It's very interesting. The International Mineral Exploration also by Mooden. Some of the NGSS bulletin, you know, it's also there for you. Then also understand some of you that might have joined this program are not registered on the our mentorship program. You can actually do that. And our secretary is here. She can also register you and all that. Then you have also a Telegram group. You can also do that. So that is what we have there. Then let me, before I go back to ArcGIS, definitely to show some of these database, maybe we can have some interactive section. We have about 15 minutes more on this program, 6 minutes to 6 o'clock, 10 minutes for quiz, question and answer. So I think you can unmute yourself, raise your hand, then let's have some contributions, comments, and questions and all that before possibly we'll go to the next one. Okay, just raise your hand so that we'll pick contribution, comment, whatever. Raise your hand so that we'll pick you, you make your comments, then okay. Okay, Dr. Mrs. Salau, please, before that, after that, Yusuf. Okay, madam.
Yeah, thank you very much, Dr. Nwafa. You know that I've been the old cargoes. While we're doing the rare earth element and the analysis in those days, we don't even pay we just pay little emphasis on all those ones that are now important. But in your presentation, do you say we have carbonatite in Nigeria? Hello? Hello, sir.
Yeah, hello.
Doctor, can you hear? Yeah, can you hear me? Can you hear me? Hello?
Yeah, hello.
Do you say we have carbonatite as in Nigeria?
Okay, now it depends. Now, when you talk about carbonatites in terms of they are rare igneous rock, definitely there are many of carbonated minerals. Now, when you have, like, if you go to Nasarawa area, do you know you have calcite there? You have dolomite there.
Yes.
You remember?
Yes. Yes.
Yeah? Rather than
Yes.
the silicate
Yes.
mineral
Yes.
typical of most igneous rocks and all that. Now,
Yes.
that is it. So if you look at it, you find out that definitely because they are very, very much rich in carbonate minerals.
Yeah.
Over 50% accessory minerals you see there are magnetites and even the apatites are the rare elements there. You understand?
Right.
So what I found out is it just the same thing also is closely related to where we are talking about in Urban Massif in Cross River. You know, because of this, the limestone, you know, most of the time you see the limestone in sedimentaries, but most of the time the dolomites, which is rich in carbonate minerals, are actually usually what we see in part of our own, which you can say, okay, what is actually carbonatite we call? We know they are very rare and they are igneous rock. We say mainly they are mainly of carbonate minerals. But in this, the dolomite are metamorphic, and in this environment too, rather than the silicate minerals. You know, so that's why we found out that most of the places in two major locations now, we've seen the dolomites, or we say we've seen the carbonate minerals around there. Those locations have high tendency of being fractionated. And so most of the pegmatite you see around there are actually fractionated. You know, but again, you might start looking at in terms of the age. You understand? And if you want to look at the pure age of the carbonatite itself and all that, their sources, they're actually significant, no matter how, in UX and all that, everything they got from their own, all the REEs, especially their Cerium and their Lanthanum, are all from that source. So in our own case, once you see dolomites in any particular environment that is associated with some pegmatite rocks or pegmatite granites, you need to closely work on that location. In short, most of the time, they are not more than 2 kilometers away. Maximum, you see 3 kilometers away within that pegmatite areas. So it's an interesting also geology to actually look at. I've seen that geology in two locations. Unfortunately, the Urban Massif, we don't even go there because of the nature of the forest. We see. So nobody wants to go into those kind of locations. But if you go in there, what you will see there is that I think that is one of the places that we've not even explored in this country. I think the only real data coming out from there was the work there that was done by Shell in 1956, when during the issue of the first work they did there was when they are looking for oil and all that. It is that particular work they did that actually revealed the real structures of that particular location. You know, apart from that, there has not been a very strong, even the recent Aeromag and some other things have not covered there. But the old ones that were done in 500 meters spacing actually covered them. But the recent tighter ones of high resolution have not actually covered that location. I believe these are another locations that we actually need to actually look at. Most of the pegmatite I noticed that was actually sampled within the Urban Massif are some pegmatite that are actually on the road, that are cropping on the road. When I took time to pick, I think I studied about more than 15 publications of pegmatite within that, all the regions and all that. I found out that all the locations that they were sampled were just along the Obudu Cattle Ranch Road, but the real locations, there are no sample coming out from some of these places. And if you look at from the map we have, you find out that that place is highly the structures there are highly messed up in terms of deformations of the structures are they're highly disturbed. You see a lot of folding and a lot of shattering within that particular region. And that is actually where we have a very sharp boundaries that we can actually define like to say unconformity boundaries, you know. So this is why we also look at that location to be a potential for some other SEDEX kind of deposit. So I think that is actually what I will need to submit in terms of that. A clue based on our own geology.
Thank you very much, Doctor. The take home here is that
yes,
whatever you are doing, if you really want to do a responsible mining, you must take soil geochemistry into consideration. Not just and you must your sampling must be thorough. Thereafter, the analysis too must be thorough. Otherwise, most of the minerals we think they are not present, in some cases, are even dominant. I have a case study at hand, which we have to go to 3 places to do the analysis just to confirm that those things that we never even suspected they are present in that location are there.
Yeah.
So
exactly. That's what I said. You know, most of the time we say we need to, because of technology and what is coming up now, there are a lot of discoveries. We can't say it's been done. They say there is not here. It is not there. Everything is possible. What we just need to do is we need to actually pay detailed attention to some of this. Let your mind be free. Don't say, I've read Geology of Nigeria. You say this is not here. I don't do that. I look for things everywhere. Anything I can find anywhere. In short, I remember when Galba was doing some presentation those days, you ask him, sir, where do we find gold? Where? He said gold is wherever it is. Wherever you find gold is wherever gold is. You understand? So you can find minerals in some locations that you never thought of. Okay. Okay, Hassan.
Yusuf.
Hassan Yusuf,
okay,
yes.
Thank you very much. Thank you very much for the lecture. So I want to ask a question as regards this Nasarawa that is part of the presentation title. So this NMGS geochemical data, I've worked with it. So while writing my report, I stumbled on one paper written in 1983 by Stiles and Young. So they work on Afro ring complex. So after working with the geochemical data, I realized that ring complex has a lot of anomalies in terms of REEs. So I want to ask, is there any work being done in exploring that ring complex in Nasarawa?
Exactly which part? Can you localize the location? Complex.
Where?
No, just the ring complex as a whole. So I don't know the exact location they work in, but they mention of the ring complex.
Yes, that's what I'm saying. Now, that's what I'm saying. Now, it depends on where you are working. When you're talking about it is about something. I think you have experience with a particular location. I've worked in various locations in Nasarawa. You understand? I've worked in various locations. I've worked even down to going to Plateau and all that. So it depends on that. I'm thinking, even not all the pegmatites, there are some bare and unfruitful ones that you can actually see. Some people, most of the time, even sometimes, the one that people reported those days that they are not fruitful, let me tell you, they sampled, some of their samplings were based on the suffix, and they published their report and say the pegmatite of these plaques are not fractionated, they are not of REE potential. There are some reports you will see. I understand some reports you will see. They will tell you that some of these pegmatites here are not they are not of REE potential than other. Let me tell you, the first time I started in Nasarawa, what I did was to visit. I mapped the entire locations where lithium pegmatites had actually been mentioned. I went to various, I did work, tried to sample about over 20 locations within the Nasarawa State down. Then Even some the location that were reported in some publication then that they are base, they ring that some of these pegmatites are not really rich and all that. Some of them location today, they are mining lithium in those locations. You get it? And definitely, let me tell you, the problem we also have that we'll talk about lithium. In most of the places where deep lithium have been mined, if you check it very well, there are some other rare elements within that pegmatite that they are also carrying. Do you understand? The Chinese will not come and tell you that there's a rare element inside this one. They are paying for it. What they are paying, the money they are giving to you is for lithium. Do you understand? So it will be very difficult for you to see lithium pegmatite that is not associated, even if it's not there, just closely, it's not associated with some other rare element, especially ND. You get ND in it, you get yttrium and all that. You understand? And even session. So this is the case in that location. Techno, yes. What is your question?
Good day, sir. Good day, doctor.
Yep.
Okay. Well done for the presentation. My name is Kaumo Soyusu.
Okay.
I have question like this, sir.
Okay.
As a geologist, what
Yes.
are the possible instruments you need to use when carrying out exploration of rare earth metals?
Okay.
Rare earth elements when in exploration. Number two, how do you understand a structure is being fractionated?
Okay.
Number three, like some other part of Bauchi State where they are mining monozites, the artisanal miners there only use when they fetch the placer deposit, they wash all of that things. So when they carry it to the company, I noticed that only magnetic analysis is being done to separate iron, zircon, and the monazite. So I want to ask if there is any other analysis apart from that magnetic test that they've been carrying out for monozites.
Your first question is now. Let me tell you what they do.
Yes,
let me tell you. Okay, let me just start. Your first question is what equipment do you need as a geologist, right? When you talk about equipment or tools, first of all, for you to be able to use any data, you must be good. Minimum application every geologist should know how to use is ArcGIS. That is number one, two.
Yes.
If you must do any mapping, no matter how it is, you must know how to use ArcGIS, and you must know how to interact with your ArcGIS, GPX, and your locations. You understand? We've done this before, and there are a lot of videos on that. You can go to YouTube channel. It depends on how far you want to learn.
Okay,
now, that is one. Then secondly, when it comes to geophysical equipment or geochemical tools equipment, now, whatever you need to find in the field in terms of geochemical mapping, definitely you need to analyze those samples. Apart from understanding how to sample them, how to grade them, because your sampling must be systematic. There are different methods of sampling, maybe randomly or haphazardly or system or profiling and all that. But it must be systematic. It must be graded. Were you here in the last training? You understand? It must be systematic. Now, being systematic means that you need to say if you are sampling 20 by 20, you are doing every 20 meters. You say, okay, you need to do 20 by 30, like that and all that. So in the entire location, those samples need to be analyzed. And the cheapest way I've seen that you can analyze this sample fast to at least bring out some element first. Like there's an element, there's one I sent to Australia, but before I sent it there, I've already done my first whatever here. You understand? Do my XRF here, understand some elements that are showing up. Then I now want to test further and understand if these elements are actually okay. The concentration are very okay for me to actually move further. You understand? So you need to know those things. And in terms of that, the third question you're asking is the method they use in terms of for monazite. Now, why do they use that? What they just need, let me tell you, what they are doing here is not actually processing. I would say the process have different standards and different methods. Now, or let me say different stages, actually, rather. Now, what they're actually doing is just to remove basically the metals, I mean the ions. Do you understand? The magnetites.
Yes, sir.
The magnetite, that's actually what they are removing, and it's very easy and it's cheaper because the magnetite is very cheap. So and that magnetite will actually give it weight. You understand? So instead of them, so they want to know that if they are carrying 10 kg, they know that 10 kg is 10 kg. But if there's some iron in it, those iron will make it, weigh so much. And at the end of the day, they don't. And these are all black metals. They are all black metals. They are all black. You understand? It's black sand now. It's just like if you now want to go further, when you now go further to separate, that's when you now understand that those minerals, those metals are separated into different metals at the end of the day. It's not done here. What they are just doing here is just beneficiation, just primary beneficiation in order to concentrate it. Do you understand? I have close to what they are looking for. What they are doing is not the final product. Do you understand? It's just like the same thing that is done in the rutile industry in Sierra Leone. When you go there, you see a major kind of separation and order. So what are they trying to do? Just to remove the iron there. Then Shamsuddin, what is your problem?
Good evening, sir.
Okay.
Thank you for the amazing session. It's very insightful. So my questions are: firstly, what is the connection between what is lying underneath, like the mineral deposit, and the soil? Secondly, how does this indicate? I said my first question is: what is the connection between what is lying underneath, like the mineral deposit, to the soil? Secondly, how does these indicators get into the soil? And lastly, between the soil and this intruded, for example, the intruded deposit, which one is younger, which one is older?
Between what?
Between the soil that we are actually analyzing for the possible anomalies and also the deposit lying underneath, which one is older, which one is younger?
Okay. You and your father, who is older? You and your father, who is older?
My dad is older, definitely.
Your dad is older. So you and your dad, who is the rock and who is the soil?
The father is the rock, while the son is the soil.
Okay, now that is one. Now, when you're talking about soil actually are just weathered from their particles from the rock. Is that not true?
Yeah, they are product of the rock. That's what weathered.
Now, let me answer your major question. The other one you are talking about in terms of how do they get to the soil. If you remember when I was talking, I made mention of the movement of heavy rare elements and light rare elements. Yeah. Some elements migrates. Some elements can easily dissolve in water or in acid or sulfuric acid, right?
Yeah.
Now, because there is water movement, there is interaction, there is pore space, there is porosity, and there is permeability. Is that not? Now, once this migration happen. Now, you ask me now, for example, how does gold come to the soil for you to detect there is gold and all that in lateral? How? It's weathering now. It's a high intense tropical weathering that gives you some of these things. Now, it's just because, for example, gold can actually come to the surface, be migrated to the surface through the action of water, because definitely when water comes inside gold and there is sulfuric acid, which can leach them out. That's what we call leaching. You understand? Some of these minerals are leached and they migrate. These are some of the things you should be careful when you're doing some exploration. Let me tell you, if you don't understand this principle, in geophysics, it can kill your career. Do you know that if you have, okay, let me give you an example now. Let's say you're looking for a lead zinc, or you're looking for a mineral, and this lead zinc, remember that they are in structures. Is that not true? Yeah, and remember that these structures, most of the time, do not just hold only mineral, it can also hold water and weathered materials. Do you understand? And your equipment can easily detect, the anomaly will be even very strong. because the mineral you are looking for are in solution. So the equipment and the current flow, because the water conducts very well, it can easily give you the highest anomaly and not even the real massive mineral itself in solid form. Do you understand?
Yes, sir. Yes.
So that's why when you are doing some exploration, you need to combine some geophysics up to 3 methods and all that. You get it? So because of that, those minerals can move. They can move through the fractures. They can move through the pore spaces because there are interconnectivity. Now, why is it that Libya is yielding the highest oil? Why? Have you asked yourself, why do we have the highest oil in the desert? Why?
I will not.
Do we have sandstone in the desert?
Limestone. They're mostly limestone, I guess.
Limestone. So why do we now have the oil there? It's because of the highly fractured limestones within those locations. Now, why? Because when they are highly fractured, the migration is very intense, even higher than what you can see in the pore spaces of sand. Do you understand?
Yes,
in
sir.
Nigeria, it is believed that the source rock of Niger Delta oil is from Anambra and is found in the Niger Delta. Most of the rocks, I don't want to go into petroleum because I'm not, but I know certain things in terms of principle, that most of the rocks that actually conducive for them to actually the trap are where they are. But the source rocks are not there. It's migration. So the reservoir rock are actually different from the source rock. It's because of the properties and different tendencies that makes them to be a reservoir, makes this one to be a trap. So it's that's why we have the higher level of mineral in terms of mineral. They still have the hypogene and they have the supergene. You remember we have the supergene and have the hypogene.
Yes.
You remember? Why? Why do you have this and hypogene? It's the migration to the surface and the one that are far below the subsurface. So that's how you see them. So that's why when you want to pick, we look at saprolitic level where the oxidation has actually happened. That's why you don't pick the black sand and start testing for, unless you want to do agri, you want to check, you want to do plantation. But in geology, what do? You go down to the saprolitic level. Is that not where the oxidation has actually, it's believed that you look for that brown and reddish one. That shows you a kind of weathering that actually the extent of weathering. So these are the things you look at in terms of sampling. Not that you have to go and do sampling, you go there and you are collecting black sand. It will not tell you anything. And sometimes it might not migrate, it might not tell you. Now, let me tell you, from my experience, I also find out that zinc moves more than lead. If you want to do soil sampling, zinc migrates easier. The mobility of zinc is higher compared to lead. If you come to uranium, the mobility of uranium is higher compared to thorium. Potassium is highest compared to uranium and thorium. That's why potassium can easily be seen mostly everywhere. You can even use potassium to even map water bodies. But you cannot use thorium to do that. So you see, different elements have different tendencies to move. Yeah, is that clear?
All right, sir. Thank you very much, sir. Yeah, that's clear, sir.
Our time is fast spent. Okay, that's fine. Let's go back to, let's just do the final one. Okay, we'll now do our, what else do we have? Okay, let's do our quiz. Then we conclude on, we will spend 20 minutes on this. Okay, let's just spend about 5 minutes doing this quiz. Right? Is that okay? The way we did it
Yes,
the
sir.
last time. Let me see if I have the, okay, it's here. Can you see it now? Can you see it now?
Yes, we've seen it.
Okay.
How many elements are
B.
B17.
Huh? B?
B.
Okay.
Sediment.
If you are answering, know our major this thing. Huh? Please, I want to answer. Just say your name immediately. Eh?
My name is
Say your name.
Musa Yusuf. My name is Musa Yusuf. The answer is B17.
Okay. Before I go further, the people that are actually doing soil sampling work now in Kwara, are any of them here? We'll send about 4 of them to Kwara. If any of them are here, or they may. Okay, maybe they are in the field, definitely. Okay. Because if they are here, I would have wanted them to share their experiences, especially what we are talking about now. I would have wanted them to share their experiences. Okay. Okay.
Yeah.
Okay, let's go. So the next one. Which of the following is a lighter element? Are you there?
Yes, sir.
Who is saying now? Which of the following is a light
my
element?
name is My name is Musa Yusuf. The
Yes.
answer is C.
Correct. Number 3, which rare element is mostly used for making strong permanent magnets?
My name is Musa Yusuf. The answer is B.
The answer is what?
B.
Wrong answer.
My name is
My
Hassan
name
Yusuf.
is Deborah, and the answer is C.
The answer is correct. Deborah is correct. The answer is C. Okay. Then number 4, which one is probably found in xenotime mineral?
My name is Musa Yusuf. The answer is B.
It's wrong.
My name is Tony Shamsuddin. The answer is A.
It's wrong.
Hey, it's wrong. What? So Cesium rather. Maybe Cesium. Cerium.
The answer is C. Okay. Number 5, which one has the highest price per kg among the ones we discussed?
B. My name is Deborah.
Deborah, correct. B. Which element, okay, number 6, which element is often considered an indicator of highly fractionated pegmatites?
My name is Hassan Yusuf. The answer is A.
The answer is A, correct. Okay. Phosphorus in soil anomalies often suggest the presence of what REE-bearing minerals?
My name is Hassan Yusuf. The answer is B.
The answer is B, correct. Who answered? Musa?
Yusuf Hassan.
Okay, Yusuf. Okay. Number 8, which element pairing is a good geochemical ratio for detecting REEs? Fractionation.
My name is Musa Yusuf. Musa Yusuf. The answer is A.
Yusuf got it. The answer is A. Okay, what kind of host rock are often linked with LCT pegmatites?
My name is Enlai Deborah, carbonatites.
It's wrong answer.
My name is Tony
My name is
Shamsuddin.
Granitic pegmatite is what actually LCT is. Always everywhere in Nigeria now. We don't have carbonatites.
Yes.
It's everywhere in Nigeria, LCT pegmatites. Yeah. So the presence of aluminum in soil anomalies can often indicate what type of geologic environment.
My name is Deborah, ultramafic intrusion.
No, it's wrong.
My name is Musa Yusuf. The answer is C.
The answer is what?
C.
The answer is correct. Yusuf has been, I think Yusuf is leading. The answer is C. Lateritic weathering is actually more of aluminum. You should know that the bauxite and all that is found in weathering. So then the number 11, which of these methods is most direct to identify buried mineralization?
I think that's an use of drilling.
Drilling, Yusuf is correct. Then we'll have which geophysical survey is typically most useful for RE exploration?
As an use of radiometric survey.
Radiometric, correct. Which exploration method is considered most cost-effective for early-stage RE exploration?
Soil geochemistry. Soil geochemistry.
Soil geochemistry, Shidin, correct. Which global RE deposit is famous for its carbonatite-hosted mineralization? Very, very famous. Very, very famous.
Australia.
As an use of Pass, USA.
It's USA. USA is correct. That is the most popular carbonatite locations in USA. Then why are heavy REEs generally more expensive than light REEs?
As an use of the answer is C.
They are rarer and harder to extract. Correct. Okay. As of 2025, which country dominates global RE supply?
My name is China.
China. That one is giveaway now. Which critical metal discussed has a high price? Is often sought as byproducts.
Scandium.
Yusuf. The answer is B.
It's wrong.
Sonny Shamsuddin. Praseodymium.
The answer is C, correct? Okay. So which major global factor caused RE price spikes in 2025?
My name is Deborah. C. Chinese export restriction.
Yeah, correct, Deborah. Okay. So the last one here is, which is soil geochemistry considered essential? Why is soil geochemistry considered essential for?
Sonny Shamsuddin. A.
It's
the answer is C. Correct. Thank you. That is the end of the quiz. I think the man of the day is Yusuf, right?
Yes.
Is that agreed?
Yes, sir.
Yeah. Yusuf is the man of the day. So we'll give it to him. I think I've picked, okay, the last time was who and who? Alkali and Abigail, right? And today we got another name. Okay, Deborah seems to be second today or thereabout. Okay, so I think that is it. We're going to draw curtain for today's training. I'll send you the presentation and all that. Then what you need to do is go back, clearly look at that. Now, what you need to do is to understand the ratios. There are a lot of things in that if I keep explaining, try to explain, it might take us a lot of time. So do that. You might also come back with or even in our platform, you can actually throw your question on your platform. So we can also answer it. You don't need to wait for that. Right? Okay. Do we have any other question? Okay. In the absence of another question, I think we declare this closed. And have a great day and a good night rest ahead of you. Thank you.
Thank you very much, sir. Have a good evening.
Okay, bye.